Welcome back, students. In this video, we are continuing talking about vector analysis, and I'm going to talk about vector data editing and cleanup operations, as well as buffer zone operations. Those are analyses that are very much important in GIS. They are very, very much common. We're going to learn about them in practice as well. But first, let's talk about theory behind it. So, vector data editing and post-overlay cleanup operations have several very common GIS operations, namely clipping, updating, dissolving, merging, and eliminating vector datasets. And let us now go one by one over those editing and cleanup operations to understand how they work. And the first vector data editing and cleanup operation is a clip operation. This is a very much common operation when we have one extent, the layer which has one extent. For example, here we can see a polygon layer showing a land use and land cover within the study area, and we would like to clip it to certain extent. For example, this the extent here is much bigger than our study area, and we need only to work with our study area. So the principle behind clipping is the same principle as polygon and polygon overlay, and we use a template which is clip feature in this image to adjust our input polygon borders, and the output is a polygon which which is clipped to the extent of our clip feature. And here we have an example. So here is our input layer, and we would like to, where the borders, as you can see, quite generalized, and we would like to clip it to this polygon with more pronounced polygon area. And the output, the result of this analysis would be this kind of layer that looks that is clipped to the extent of our second polygon, which is a clip polygon. The second quite common operation in data editing and cleanup is update. And in this operation, the data is modified in a separate layer and then added to the original data, replacing the old features. So how does it work? We have our input coverage, and we would like to update this part. So based on this update coverage, our input coverage, and the output coverage would look like this. And let us have a look on this concrete example that you would see how it works. So here we have our extent, and we would like to update this part. So this is our update polygon, and when we apply update operation, the output looks exactly as an input feature, but this part of our polygon will be updated. Another important operation in vector data editing and cleanup is dissolve. Basically, dissolve uses attributes to aggregate unit polygons into new larger polygons which contain at least one common attribute from the smaller polygons. So the prerequisite to apply dissolve on two polygon layer is the availability of the same attribute column in attribute tables of both polygon layers. Yeah. And in this example, we have municipalities with county codes as attributes, which is an input, and our output will have a dissolved municipalities into counties. Yeah, so the both layers had county as a attribute table, and this with an attribute table, this allowed us this dissolve to perform the dissolve operation. Merge will bring together two adjacent in space data layers in order to create a larger database. And well, you can see the input looks like this, and the output basically would have a bigger extent. Yeah, so here we have one polygon, second polygon that are in space adjacent. This is very much important, and the output would look like this. Eliminate. Eliminate is important GIS operation that is used to eliminate polygons with an area less than a certain threshold value. And usually it's used to remove those slivers that resulting from overlay of two polygons that I have been talking previously. So here's our input coverage, and our in yellow you can see those very thin small polygons. Those are those sliver polygons that were created as a result of overlay of two polygons. And when we eliminate, we actually have to specify the area of polygons that have to be removed. And as you can see, the output is a smooth, nicely created polygon. Now we are going to talk about advanced distance operations, which is a buffer zone operations. So buffer zones, they look like this, and buffer zones could be polygons. Well, basically the buffer zones is a polygon layer, yeah, that is created and could be created using as input either point layer, lines, or polygons. So if you have data sets that represent other points or lines or polygons, so the data here as a points could be the wells that we were talking as well. Lines could be roads or rivers. A polygon could be cities. And for any of your operations, sometimes we need to create buffer zones. Then you could create buffer zones over all of these three types of vector data sets. And how does it work? First, we are creating parallel lines on each side of the original line segment. So in this example, we take a line as an input vector, and the buffer zone is calculated be- in respect to this line. And first we create parallel lines on each side of the original line segment with the same length, but at a distance equal to the buffer distance. Yeah. So basically, when you specify that you would like to create a buffer distance of 50 meters, it means that 50 meters will be added from right and left hand side from your input feature. Yeah. Then this follows with connecting endpoints with arcs that looks like this, having a radius equal to the buffer distance. So the radius of this would be equal to your buffer distance. And buffer zones have two major steps when they are creating. So the calculation of coordinates of a buffer is done for every single element in your buffer polygon, and as well as merging of overlapping buffer zones. And as I said, these operations are done in background. You, as a GIS expert, you don't need to specifically do or input any algorithms. This is already pre-programmed in QGIS, in ArcGIS, in SagaGIS, in any other GIS program. But for us, it is important to understand how it works before we apply this in our next labs.